All right, this entire lesson's all about compound events. We did this little activity in class, got to look at how these locks and which one is actually the best possible lock based on the number of outcomes for each individual digit or letter. So that was kind of fun. Hopefully y'all got to see something out of that. Let's look at some vocabulary that we need to make sure we're aware of. The first one we want to look at is the word sample space. The set of all possible outcomes of one or more events is called the sample space. So for instance, in class earlier, up here in our examples, we looked at that there are, for this first number, the 4-digit example we did in class, the first digit has a possible 10 outcomes, and this one has 10 outcomes, and this one has 10 outcomes, and this one has 10 outcomes. And if you multiply those out, that gives us a total of 10,000 possible outcomes. That would be our sample space. So for our vocabulary, the total number of outcomes is going to be considered the sample space. Visually, you can represent this using tables and tree diagrams are two things that definitely help out a whole bunch in visualizing the sample space. So that's to lead us to our first example. First example here involves pizza. I apologize for being food. Some of y'all might be hungry at this time. So it says you randomly choose a crust and a style of pizza. Find the sample space. What is the total number of outcomes? How many different pizzas? So we can do this by doing a visual example first. So we have 2 crusts, thin and stuffed, and then we have 4 different styles of pizza: Hawaiian, Mexican, pepperoni, and veggie. So using a tree diagram, we can actually represent this. So first, we're going to start with thin crust. Okay, these are thin crust pizzas. So we can start with a thin Hawaiian. That's one style. A thin Mexican, thin pepperoni, and thin veggie. So that represents 4 different total outcomes so far. Then we go back into the other crust. So we have stuffed Hawaiian, stuffed Mexican, stuffed pepperoni, and stuffed veggie. That's 4 more, so we have a total of 8. And we did that using a diagram, a tree diagram. Okay. The next one involves a table. Okay. Find the number of possible outcomes of rolling a number cube. Well, a cube has 6 sides to it, and flipping a coin, there's heads or tails. So let's draw a table to represent this. You can do this by putting all the possible outcomes on the exterior of the table and then combining them almost like a multiplication table. Okay, so you have your heads and your tails here, heads, tails. Over here you have the different outcomes for your dice. So notice 1 head, 1 tail is an outcome, 2 heads, 2 tails, 3 heads, 3 tails, and so on. So you'll notice here the total number of outcomes, our sample space, is 12. We have 12 possible outcomes from this table. Okay, so you can see those are the visual representations. They definitely help out. I prefer mathematically, but those definitely help visually. The next one, which is the math one, is called the fundamental counting principle. Okay, the fundamental counting principle says an event M has M possible outcomes. An event N has N possible outcomes. The total number of outcomes of an event M followed by event N is M times N. This is when these are dependent on each other. These examples up here, okay, in order to get the password right, it's dependent on the first one being right, then the second one right, and third right. So we had to multiply them, right? So this first example here in the A, you have a 1 in 10 chance here, you have a 1 in 10 chance for the second one, but to get the whole thing right, those first 2 right, it's a 1 in 100 chance because 10 times 10 is 100. But for the whole thing, if you want to get 4 in a row right, that's 10 times 10 times 10 times 10. That'd be 10,000. So the fundamental counting principle says you take the total number of possible outcomes from each one and then multiply them out. Okay, so a next example would be right here. I know it may be hard to see on your computer. We have the following. So t-shirts, looks like we got 1, 2, 3, 4, 5, 6, 7 t-shirts. We have jeans, I think it's 1, 2, 3, maybe 4, and then 3 pairs of shoes. So we'll use that. So 7 possible t-shirts, 4 pairs of jeans are up here on the top of the shelf, and 3 possible shoes. So using the fundamental counting principle, we can just multiply these out, and we end up getting 7 times 4 times 3 is 84. So we have 84 in our sample space, 84 possible outcomes. The last one, I think is one more example here. Example number 4, actually there's 2 more. For example 2, what is the probability of rolling a number greater than 4 and flipping tails? So if you think back to that last example in example 2, the probability of rolling a number greater than 4. Well, we have 4 possible outcomes more than 4. You have 5 heads, 5 tails, 6 heads, 6 tails from examples. But they want to know how many are tails. So in that case, it's only 2 of them. Okay? So there's only 2 favorable ones out of a possible from that list was 12, 2 twelfths, which simplifies to 1 and 6. Okay, so the probability of us rolling a number greater than 4, so 5 and 6, and flipping tails is only those 2 other ones, so it's going to be 1/6 there. All right. Last one. I lied on the previous one. Example 5, last piece of the puzzle. You flip 3 nickels. What is the probability of flipping 2 heads and 1 tails? Okay, so the probability, we're going to use a tree diagram. Okay, in this one, you start with the first one, heads or tails. That's your first one. You have a 1 in 2 chance of getting that one first there. Next one, you have heads, tails, head, tail for this one. Then the third one, do heads, tails again, heads, tails again. So here are the outcomes. If you like follow on the tree diagram, this one's heads, 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 tails, and so on. You'll notice that we have 3 possible scenarios where we can have a favorable outcome of 2 heads and 1 tails, and there's a total of 8. Okay, so we end up seeing that 3 out of 8 there. You could also use the counting method, knowing that you have a 1 in 2 chance. So you get 2, 2, and 2. 2 times 2 is 4. 4 times 2 is 8. And then you just figure it out that there's 8 total outcomes there. Hopefully that helps, and I'll copy that down, and I'll see y'all on Thursday.